Well, hey there, class. Hey, Troy. Looks like we made it. Made it all the way to the end. Can you believe it? And I'm done. I made it through the finish line here. So first, I'm going to give you guys some shots of what we had, what we ended up with, and then I'll give you some real life images of where we are with the real project as we speak. Here, a week away from turning it in, and then I'll give you the numbers breakdown. So yeah, here we have it. I've got the two Fennec robots. This is just the general overview. They're facing each other. One of them has a gripper arm on it, and the other one has got a vacuum arm on it. I don't have any of the connectors shown here, of course. That would be way beyond the scope of this rendering. Underneath there, we have the turntable, the Lazy Susan that rotates around. Those are the parts on top of it. Well, let me just kind of start zooming in and I'll take you through it. Let's see, I'm kind of trying to rig up. I've got a video in here, so I'm trying to rig it up. Let's see. There we go. Yeah, here's a shot of that turntable. This rotates back and forth, and that vacuum arm, the vacuum gripper there, picks up the pieces and sets them. There's a bottom piece, and then the membrane sets in between them. This one here actually is usually flipped around. So the bottom piece, membrane, top piece. This right here is just a magazine that this piece, the gripper arm, will come over and grab these dowels and press fit them through. So the vacuum assembles, the gripper presses through the dowels. Of course, those are both pneumatic tools, so in the real life setting, we had to design the schematics and set up a bunch of pneumatics for it and everything like that. But we'll go through it. Let's see if I can get this running again. So fast forward. Here's a close-up of that pneumatic gripper arm. Again, this is all stuff that challenges we faced in real life. When we were first given this gripper arm in real life, it did not have these grippers, and it did not have a bracket or any way to mount it to this robot. It was just a little chunk of pneumatics with these hoses sticking out of it. So true story. I used my rudimentary SolidWorks knowledge way back at the beginning of our course and designed those gripper arms and had them 3D printed and implemented here in the capstone. There's 4 or 5, maybe 6 pieces that I actually designed as part of the SolidWorks course that did get incorporated into our capstone that we wouldn't have been able to do the capstone without my SolidWorks knowledge. If I'm being honest with you, we would have muddled through it, I'm sure. Okay, this is a particular challenge. This is a bracket. I should have shown you a better shot of those robot arms, which I'll show you later. But keep in mind that the robot arms, the armature is all connected in real life with these kind of spheres that are sheared off at one end. So there's a sphere and then another kind of hollowed out sphere around it. And in real life, these joints have a ton of lateral motion because it's sphere on sphere. I tried to simulate that. I got the geometry at one point, even though it was a bit of a pain. The geometry is not correct for that in this. We do have the sphere on the inner one, but the outer one is just a regular cylinder and not a sphere. But even when I did get it to be a sphere temporarily, the mating is just too complex. I'm sure somebody who's a lot better, but I just didn't have the time. So it functions, and you'll see in my video that the arms are all mated and do go up and down, but this kind of real life lateral motion I just wasn't able to obtain because the mating was just beyond the scope of my knowledge. Here's a shot of the vacuum cup that we designed and built and is now currently sitting on a real life robot sucking air. Moving on. This is underneath the table, that wood table that you saw. You might have been curious. Underneath that, this is a worm drive right here. This is a worm. Whoa. Sorry, I forgot to pause that. Okay, pause. Okay. So this is, of course, the table, and underneath the table, this red piece is there's a worm drive that goes in there and rotates. And that's connected to a rotating piece here. The black part is the part that actually rotates. So all the red stays still, and the black part will rotate, and the black part is screwed into the table. There's a stepper motor, not modeled here, but in real life there's a stepper motor connected to the back side of that worm drive that is connected to a PLC that causes that to rotate. And you'll see an image of the PLC and stuff here at the end. You'll see that that strut, which was in my first presentation, which was quite large and geometrically complex, we needed 3 inches lowered, so we were able to break down some of that geometry and make it quite a bit smaller there. Okay, moving on to the next video or the next image. Yes, here is the final gripper arms armature setup. As you can see, it all went together quite well. There was bushings and things that needed to happen to make it all work. Like I say, it goes up and down, and you'll see a video of here in a minute of it going up and down. But the kind of magic that this FANUC actually does in real life, it won't happen with this model. Let's see, maybe this will be the video. No, just another shot, further away shot of the arms. And then here we'll have a video here next, I guarantee. Yep, here we go. You can see down and then stretch and then back up. Yeah. So they all do that. Okay. Again, this is a shot of the final assembly. I can make this table rotate. Might as well use the mouse pointer. No, you can't see that very well. I can make the table rotate. I can make the end of arm tools here on this rotate around, and I could have made videos showing that. But to be honest, at the end of the day, there's 90 components in this overall setup. And my computer, I did this whole thing on a little Dell 2-in-1 that's 5-year-old, and it's kind of reached its peak with when I have the full thing up and showing like this. It doesn't like it. So I think next I have, yeah, this is what it actually looks like in real life. So your eyes got nice and used to that beautiful silicon digital world. But hey, baby, if you want to get into mechatronics, this is what it all comes down to. You'll see the grippers. Of course, we've got the actual motors exposed in this one. PLC wiring. There's pneumatic lines in there. We've got the laptop hooked up in there. Now, guys, this is due in less than a week. It currently does not do what it's supposed to be doing. We blew 2 fuses this morning, and we couldn't proceed with the project until those fuses show up, which they're being sent to us, and hopefully they'll be here on Monday. But we gotta do what we gotta do. The project's got to run on Thursday. That thing is going to be up and running. Come hell or high water. I mean, we'll make it happen, but that's what life is like here when we live on the edge. Oh gosh, I haven't even gotten to the breakdown yet. This video's running long. Sorry about that, guys. Okay, breakdown time. Oh, it's totally backwards. Well, I'll just have to kind of explain it to you then. I've got a paper format of it, but you know, I'm recording this with my image cam, my face cam. So I'll just tell you, on 6.5, I had 6.5 hours. I generated 5 parts and an assembly. On 6.6, I had 5 hours. Oh, this gotta be so annoying to look at that backwards. On 6.6, I had 5 hours, generated 7 more parts. I had previously generated 5 parts that we used in the model. I credited myself 2 hours for that. And on 6.7, I finalized the project. But the important numbers here in reverse are total number of hours obtained, 30.25 hours. Total number of unique parts generated, 34 parts. And total number of components in that final assembly that I showed you guys was 90 components. So, yeah, again, sorry about that reverse. So I should have thought better about how they, the selfie cam reverses things. But yeah, said and done. Tired as hell, don't mind telling you. And in real life, we've actually got to make that thing work. So I could use some thoughts. I could use some prayers. Whatever gods you believe in, please have them look at me next Thursday and smile. Okay, thanks so much.